Good morning, good evening, good afternoon, everybody. Welcome to one more online learning session on the topic of gas flow measurement. It's a very challenging topic, and that's the reason why we have many experts today in our panel. Which technology best fits your application? That's the typical question everyone gets, and we are going to try to solve this, let's say, difficult problem and find a solution to this. As we are in oil and gas seminar, online seminar, we would like to focus on the safety moment over here. At this moment, considering the pandemic situation, we would like you to focus on the fact that you keep social distance, wherever possible, wear a mask so that you can be protected against this deadly virus. Also, make sure that you use the tracking app which your government offers, and if possible, get yourself vaccinated. The safer you are, it's better for your family and your company as well. All right. Having said this, I would like to also mention that this series of online seminars are actually sponsored or organized by Endress Hauser Group. That's the headquarter which you see on the right-hand top corner. It's a 2.6 billion euro company with over 14,300 employees. Having said that, it has a very strong equity ratio of 76% and over 8,000 patents to ensure that all the new innovations which we are developing, this adds value from our side to solve your problem. And now coming to the topic of today. As I mentioned, gas flow metering is a very difficult topic. And today, the way we are going to go about with our agenda is the following. We'll start with the gas basics. So we'll talk about ideal gas, real gas situation, and why you need compensation in certain topics, why you need to get inputs from a gas analyzer as well. And then we will focus on each and individual technology which is being used for this particular gas measurement. On your right, you see we have Oliver Seifert, who is expert for vortex flow metering system. Then we have Erwin Doorenspleet on the right-hand bottom. He will be talking about gas ultrasonic flow meter. Top left corner, Rodrigo. He will focus on discussing how to use Coriolis flow meter for natural gas applications. And Matthew Hull will talk about thermal gas flow metering being used in numerous utility applications. And having said that, I would also like to focus on simple housekeeping. Today's presentation is available in the handout section of the GoToWebinar platform. And with this, I will hand it over to Oliver. My name is Janish Kiwala. I will be your moderator for today. And if you have any questions, please feel free to put it in the chat box of the GoToWebinar. Over to you, Oliver.
Thanks a lot, Janish, for this kind introduction. So, hello, I'm Oliver. I'm 52 years old and for more than 20 years now with the company. So on a private notice, I'm married, I've got 3 kids, and I'm pretty active on LinkedIn. So if you don't follow me yet, please feel free to do so and just scan in the QR code that you see down on the bottom right. So let's go to the next slide. And here we see already some gas basics. So the ideal gas law is actually formed of 2 parts. It consists of 2 parts. You've got the Boyle's law, which you can actually apply yourself by taking a bicycle pump. You close the piston, you close the valve, and you apply pressure to the piston, and you see how pressure increases. Pressure rises, so the volume is proportional to the inverse of pressure. So with the first application. So on the next slide, we see the second part of ideal gas law, and this is Charles' law or in the French-speaking world, it's also known as Gay-Lussac's law, and that was found in 1800. And this is actually the foundation of flying with a hot air balloon, so with a so-called Montgolfier. So the first pilots, actually, you can see that on that stamp from France, that were Pilatre de Rosier and Marquis d'Arlande. So you increase the temperature, what happens? The volume will rise of that amount of gas, and through that, the density in this hot air balloon is going down, and that's why it's rising and going into the air. If we now, on the next slide, put together these two parts of the ideal gas law, what we get is PV over T is constant, so pressure times volume over temperature is constant. And an application, a simple one, is you always are striving to check the pressure of your car's wheels when you have a cold tire. If you're driving a car for a longer distance, what happens? Temperature increases, but also through that, because the volume stays constant, the pressure is going up. So that being said, nothing is perfect, nothing is ideal, and we have to accommodate for a certain real gas behavior. And that happens through the compressibility factor, or Z factor, or real gas factor. And we see typically at low pressures, this Z factor will be smaller than 1, but relatively still close to 1. And if you go to higher pressures, then you will see Z factors that are higher than 1. That means that forces of repulsion are getting stronger in that case, and the gas is less compressible than ideal gas. And that's very important. We see gases are compressible. Rodrigo will talk about that. Typically, for a gas, you will always strive to calibrate a gas meter, if you can, on a liquid, and not on a gas. Only if you have to, you will do so, because the best gas rigs that you find, they are in an uncertainty range of maybe 0.3%, and the best liquid rigs that you get are in the range of 0.015%, so a factor of 20 better. Talking about the Z factor, you see there are certain equations available, like the AGA8, ISO 12213, and those are typically in your flow computer or in your gas analyzer. So if we go to the next slide, here we see the different sources of error you have in a volumetric solution that has to be compensated, because corrected volume, non-meters cubed or standard cubic feet, they are referring to a certain reference condition, like 1013 millibar or 13.696 psi, and a certain reference temperature or pressure, 0 degrees C or 60 Fahrenheit. So you have a lot of different sources of error. If you compensate now a DP solution, if you compensate a volumetric solution, you need to make sure pressure is correct, because are you using gauge pressure or absolute pressure, which is a potential error. You need inlet runs, outlet runs. And the beauty is now, if we go to the next slide, we see the perfect simple answer is actually direct mass flow measurement. So we will see later the measurement of Coriolis. You have direct mass measurement, and you just divide mass by the reference density. And you get the reference density again from a gas analyzer, as you see one from our own company. And the other error source is mass. And with the Coriolis, you can achieve 0.25% of reading in mass terms. And this is unachievable with all the other technologies that we're going to see right now. And with the next slide, you see a comparison of the different technologies that we will talk about today. We, of course, as Endress Hauser, can offer you on the bottom left DP flow technologies that are compensated by pressure and temperature, but we can also offer you volumetric technologies like Vortex and the Ultrasonic. So both are available with integrated pressure and temperature compensation, and the real gas equations like AGA NX19, AGA8, and so forth. But we also have, that's perfect choice for utility applications. That's the thermal mass flow meter that is also available with insertion technology, so available for large line sizes. And top of the notch, from my perspective, is actually the Coriolis technology, where you have direct mass measurement with an accuracy of 0.25%, which is unreachable for all the other guys. That being said, I'll go to the first technology that we want to check out today, and that's the vortex. So from our side, that's the Probe 200, and we have four different versions available for that. So we have a wafer version, so that is mounted between flanges. That's the Probe D200, D for disk. Probe F200 is the standard version in the oil and gas industry, so especially in the petro industry, refineries, you find this guy quite a bit. Sometimes you have to reduce the line size. The Probe R200 can do so up to 2 steps, so you can reduce from a 2-inch to a 1-inch version integrated in that device. And last not least, for high pressures, especially in the oil and gas world, we have the O200 up to class 1500. So also available as a weld-in or butt weld version. So next slide, we see here you see the technology. You see the capacitance sensor that we're using. All other competitors, they're using piezos, and they have a problem. They're drifting. Our meters drift free, and this is a major advantage of our meters. They're more robust than what you find typically on the market, and they're also long time stable and reliable. On the next slide, we see several applications for our vortex in the oil and gas field. Bottom, you see several oil fields or gas fields where our meters are applied, but you also find them in boiler houses. You find them a lot in refineries. For instance, vortex is standardized by the Shell DEP standards. So in refineries, really, we literally have thousands of applications in total. Vortex gas applications are in the range of 100,000 where our meters are installed. And with the integration of pressure and temperature, you get then also the gas equations like AGA8, DC92, or also the Gross method, or the energy calculations like AGA5 or ISO 6976. So on the next slide, you see an overview of the benefits or advantages of using a vortex meter. Our meters are universal. You can use them in liquids, gas, and steam. That's why very often in refineries you find them being used. And they are loop powered, so perfect fit when replacing a DP flow that was existing and you would use something better. It's very robust against water hammer, against vibration, temperature shock, so also perfect fit for steam. It offers lifetime calibration, so we're getting meters back after 30 years in service, and they're still showing the same calibration factor as when they left the factory. And they're also very robust against vibration. We are replacing competitors where customers say they had an issue, and using our Probe 200, those issues are just gone. The devices are, it's the first vortex meter developed per IEC 61508, so really not only proven in use. And we can offer you still 3 devices in a single device, so like the dual sense, that's 1 out of 2, or we can also offer you 2 out of 3 architectures. We have multivariable options offering direct mass and energy output, so you get the MMBTUs directly out of the meter. It's available up to class 1500, max 450 degrees C, and best accuracy you can get is 0.9%. And they're standardized per ISO 12767. The most important limitation of this technology, however, is that you have a low flow limitation. You lose the signal at low flows. That's why you should, in those cases, use reduced bore vortex meter and or do a good sizing. And the maximum line size is DN 12-inch, and we don't have custody transfer. So thanks a lot. That was it from the basics and vortex side.
Thanks a lot, Oliver. And having covered the vortex technology, now we will move on to the thermal mass. And for that, I would like to invite Matthew Hull to take us through his slides and explain his point of view.
Very good. Thank you, Janusz. The thermal mass technology is a very flexible and also versatile technology, which allows it to be used in a mixture of applications. However, very frequently, because it's also ideally suited for this purpose, and as Oliver also indicated, it's used in utility type applications very often. What my focus is today is a particular utility application dealing with natural gas, and natural gas used in combustion type applications. And I'm looking at specifically combustion gas for boilers. Boiler efficiency is a very important indicator, something that should be monitored in real time because it gives an idea about the performance of the boiler. And this may change over time. And if there is a reduction in the boiler efficiency, it could be an indication that there is a need for maybe a repair of the boiler or possibly maintenance of the boiler of some kind. For this purpose, the thermal mass can be used for measuring the natural gas because the whole combustion process does deal with mass. The T-mass or the thermal mass is very ideally suited for this purpose because it does, like the Coriolis, deliver a direct mass measurement. Also being provided by the software of the T-mass device is a so-called calorific value. The calorific value is based upon the type of natural gas used, so based upon the composition of the gas. And the software of T-mass will provide this calorific value based upon the gas that is configured in its software. This can be used for the calculation of energy flow, which again is used in the boiler efficiency calculation. Also very important to the combustion process is the air to fuel ratio. Getting this relationship correct, making sure the mixture between air and fuel is correct is very important because that has a large influence, of course, on the efficiency of the combustion and in the end also on the boiler efficiency. It also has a very large impact on the amount of harmful emissions that are released into the atmosphere. And that can also be manipulated by getting the air to fuel mix correct. In this regard, T-mass, thermal mass, is also ideally suited for that purpose. Very often, because of changing operating points of the boiler, there may be needs for low to very high flows. The T-mass device has a very high turn down, typically 100 to 1. It can also be used very well in low flows where there's also low pressures, and it causes a very small to negligible pressure drop due to its design. Also, it comes in an inline and insertion version. The insertion version is well suited for installations that may require rectangular ducts, but it can also be installed, of course, in circular pipes. Here we see in the picture on the right a combustion air application where the T-mass is inserted in a rectangular duct. The high performance of T-mass is also well suited for using in boiler efficiency calculations. Next slide, please. Because natural gas is a product of nature, it does have a tendency to change over time. And due to that change, it can have, of course, an effect on the gas's density, also on its calorific value. So certain types of measurements, for example, DP, volumetric types of measurements, are influenced by this, of course, because they are density dependent. The T-mass device, like I said before, is a direct mass measurement. There's no need for pressure and temperature compensation, no need for density correction. The software of T-mass also provides the reference density, and this, again, can be used to convert from mass into corrected volume units. Also, there is the ability to input a gas analyzer to the T-mass for compensating dynamically for changes in the gas composition. Next slide, please. To summarize very quickly, there are a number of benefits with the T-mass, with thermal mass. It is a direct mass measurement, as I mentioned. It has a very large turn down with very little pressure drop. It can be used in low to very high flows and also in very low pressures. Some of the disadvantages are, of course, that the gas composition must be known. Due to that, we do recommend a stable gas mixture. Also, the installation is important because it does need a fully developed flow profile. And the gases should be dry and clean. And with that, I would like to turn it over to Erwin. Thank you.
Thank you, Matthew. Erwin, over to you with your brand new ultrasonic gas flow meter.
Thank you very much, Janis. Very well. Well, brand new. The meter is on the market for a bit more than a year, so it's definitely not old. But when we introduced this device on the market, we had one customer in the Middle East who immediately ordered 2 devices, which was very good for business. But actually, the story behind shows us what the value of this device is. This is a natural gas application in the Middle East, and this customer has a monthly bill of roughly $190,000 of natural gas, meaning that if there is a small deviation in the meshing performance, it's immediately a lot of money. So this customer had originally a turbine installed, and since the meter was broken, was about to break or just back from repair, he was used to have 2 devices to be sure to always be able to measure. Since a turbine had mechanical parts, it was wear and tear, this was not always guaranteed. But the story goes a bit further, because this customer is measuring cubic meters, but in the end is paying his bill in energy, in BTUs. And there we saw a dispute. There was always a dispute about the bill and the amount of gas measured, because the gas supplier was measuring the gas composition somewhere at some point, and the same was valid for the temperature and the pressure. And the customer was looking also at his process and said, but listen, if I have used this amount of energy, according to you, how can it be that I have not finished my process? Because I know I needed more. So there must have been something wrong with the energy, saying the gas composition was changing. So with this new electronic ultrasonic gas flow meter, which is not only an ultrasonic gas flow meter, but also includes temperature, pressure, and a calculation facility, you can measure not only flow, but also the calorific value. That is very important for the customer, but also based on a parameter like, for example, the speed of sound, the customer can monitor the gas composition or the quality of the gas. To gain trust in the meter, he's yearly using intensively the diagnostic capabilities, and for that he doesn't even have to leave his office. He can do that using the wireless LAN and using a tablet or a computer. No interruption of the process. You can run full diagnostics of the device. And in the end, this customer is replacing not only a turbine, but also a temperature, a pressure sensor, and a calculation box with one single device. And there is no maintenance, there are no moving parts, and he has much more information from this measuring point. Next slide, please. So we really say that the Personic Flow G, our new ultrasonic gas flow meter, redefines ultrasonic gas measurement. And why is that? Because we designed this device really for challenging gas applications. Of course, it can measure dry gas, like natural gas, for example, but also can handle very well more challenging conditions like moist or wet gas, or varying gas compositions. And there the device really excels. And this capability to measure moist or wet gas, we can really see back in the capability to measure high liquid fractions. The figure on the top right explains a bit the area where we are working with this device. We say this device can measure reliably up to a Lockhart-Martinelli of 0.3, and that is something which you don't see often in the industry. A typical ultrasonic flow meter cannot do this, and the same you can say for actually all the other measuring principles. Maybe the best alternative you still have is a DP solution with a Venturi. But also with the Venturi, you have, for example, a problem with the turn down. So that is the next advantage. We have a very low pressure drop, but the device has an extreme turn down, meaning that over the lifetime of a gas well, for example, you don't have to resize the Venturi. You install once a flow meter, and that flow meter will measure from the high flow, the initial high flow, to the later lower flow situation of the well. We have this gas analysis computation functionality. We call it advanced gas analysis. That is a calculation package we have embedded in the software, which gives you really an unparalleled flexibility in gas calculations and the monitoring of the gas properties and the gas quality. Complicated formulas like you see on the left-hand side, the ISO 12213 or the AGA NX19 are all embedded in the instrument, and they just make your life easier to use these standardized calculations. Next slide, please. So the advantage of the device, it can measure and also detect changing gas compositions. It is a reliable measurement because it can also work under challenging conditions like moist or wet gas. It has a fully integrated pressure and temperature measurement, and with fully integrated, I mean it's even embedded in the diagnostics of the device. It is in the end one instrument. Due to the fact that it measures not only flow rate, but also temperature, pressure, and also speed of sound, you really have a true multivariable instrument. And those inputs are directly important for the advanced gas analysis application package, the calculation possibility I mentioned earlier. We have a very low pressure drop, means you can measure at very low pressures and low flows. This device measures from a light vacuum all the way up to 100 bar. And based on the monitoring capabilities of the ultrasonic meshing principle, it really creates a window into your process. It can tell you much more about your process than only the flow rate. Of course, the device has some limitations. One of them, the most important one, it is sensitive for a fully developed flow profile. You need some straight run in front of the flow meter. Unfortunately, we don't have a custody transfer version available. We have a line size limitation of DN300 or 12 inch, and the maximum pressure is class 600 or 100 bar. Not yet available is a material which can measure high hydrogen sulfide percentages of more than 5%. And with that, I would like to give over to my colleague.
Thanks, Erwin. Excellent presentation once again. Next in line, we are going to discuss of using Coriolis flow meter for natural gas application. Over to you, Rodrigo.
All right. First of all, thank you, Coriolis, for the outstanding introduction of these technologies. Of course, we saw how different technologies could be selected for a specific application in natural gas. Of course, we saw advantages and limitations as well. And thank you, Oliver, for, of course, introducing the Coriolis meter and tell how accurate and how stable is a Coriolis meter for gas measurement, of course. But what about when the instrument is already installed outside and you really need to prove the stability of this meter, or even to know if they're still under specifications? Well, here is when the Coriolis technology takes the lead. Since proving any gas meter in situ is very difficult, it's very complex, the stability of the Coriolis meter makes them ideal for use of gas, of course. So we can utilize the transferability of water calibration to gas, plus the meter stability, which is gained over time. And with these parameters, we can establish a very accurate and stable metering system. We could apply the following methodology as an example how to establish stability for high value gas transfer. So first, what we do is to establish the meter factor on water. So that's pretty much standard what we do with the Coriolis meters. Then, as a second point, we validate the meter factor on gas. That can be done by into a third-party facility, for example, Pixar here in Germany. And the third point will be periodically remove the meter from the service and verify the meter factor on water. Although this methodology requires that the meter needs to be removed from the service, it defines a very accurate in situ performance of the meter, since step 1 and 2 establish the meter traceability between water and gas and verify water performance in the step 3 automatically. And so by that way, of course, you get a more stable and you make sure that you have let's say, a very good performance device in gas applications. After some experience, it is likely that our customer, of course, will repeat the step 3, which is once again removing the device from the site. It will be actually extended to maybe 2 or 3 years after they see that actually there is no change in emitter factor over time. So this is very, very important and very big advantage of Coriolis meters, of course. Alternative of this proving methodology is to use a Coriolis meter as a master meter as well. So same thing, by establishing the traceability between water and gas measurement on the meter, it can be used to prove other meters of any kind of type. Next slide, please. So after we saw, let's say, the benefits of Coriolis technology when the meter, when the instrument is already installed, now we are looking into applications which are very demanding for another technologies, and where actually Coriolis has been the only technology capable to provide a long-term stability because of the robustness, compact, and overall design. So a natural gas can be stored on the ground, of course, in caverns, where there is a porous formation of partially depleted oil and gas reservoir. So what is going to happen is operations in the surface require a precise control of the amount of gas you are pumping into the storage on the ground, and of course also the one receiving out from the storage. So in other words, the instruments are used to measure gas flow in two directions, pumping in the cavern and pumping out, of course. So for this kind of applications, storage fields utilize Coriolis meters for injection and withdrawal of measurement natural gas. In this application, we will find multiple small wells, and the installations are very critical because they don't have a lot of space. So they're very narrow space. There's a lot of pulsation, there is a lot of noises, and of course, we know that the Coriolis meters are not affected by that. Also, one of the difficulties of this application is that once you pump out the gas, it's already fully saturated and even contain S2S, which actually is a very corrosive gas. And even during high flows, they will produce sand as well. So once again, that's why it's very, the Coriolis is a big advantage here in this kind of applications. Next slide, please. And the picture right here, we see an installation in Poland, as we discussed previously. And you will see that actually the space is very narrow between them. And between that kind of installation, you will have a lot of pumps and control systems, which actually create a lot of pulsations, noises, and vibrations. So can you imagine, for example, this kind of installation having inlets or outlets? I mean, it will be very complex and expensive as well. So that's why the Coriolis meter fits very good into this application. We know that the time difference between the inlet and outlet of the tube is proportional to the mass flow of the gas. So this is true, of course, for compressible and non-compressible fluids. And therefore, a Coriolis meter can measure mass flow rate for a gas application without needing to compensate for changes in density coming from pressure and temperature changes. Unlike other technologies, the Coriolis meter can measure the mass of gas even if the composition is changing, for example. Another advantage of Coriolis meters is in the installation is actually that Coriolis meters are multi-parameters. So you not only get mass flow, but you also get temperature, viscosity, and density as well. And that means that actually you can eliminate, for example, a temperature connection there. So that means, of course, you have a less installation complexity. And of course, you are reducing the number of measuring devices required, which reduce, of course, the potential of leakages, for example, right? And besides that, you don't add more uncertainty in the complete overall accuracy of the system. As mentioned before, in this application, vibrations are very common as well. As previously commented, Coriolis is very robust in these type of applications and is not affected by that. And because, of course, Coriolis meters doesn't measure velocity, flow conditioners are not required. This even further reduces the cost and complexity of the installations and allow you, of course, to install the meter when it is more convenient. So once again, big advantages for the Coriolis meter is about the installation. Very simple, very compact, very narrow. You don't need inlets and outlets, and it will be, let's say, work very well against noises or vibrations. Next slide, please. So we see here, we have let's say, original reference letter from our customer in Poland, the one we talk about it, where we have actually 47 meters, and they are working on very difficult industrial conditions as well. And the customer here mentioned very, very clearly that the design is very solid. It's very small and compact dimension of the Coriolis meter, and is resistant for vibrations, and of course, is working perfectly since many years. The flow devices, once again, measured by directional, so it's a big plus for our customers because they can utilize one meter to inject the gas, and of course, the same meter withdraw the gas. Okay. Next page. I know I'm running out of time. I'm trying to go quick. Sorry. So this one is actually the closing, let's say, slide. Here we mentioned actually the limitations and, of course, advantage of Coriolis meters. One of the main points, of course, is that we have cost-to transfer available. So for cost-to transfer application, we have the right Coriolis meter. You have direct mass flow measurement. Water calibration equal to gas calibration is a big plus. I will say, I suggest that everybody think about it because we have the issues with many customers that they didn't select the right device for their application, and they went through, let's say, a highly cost, let's say, way of calibrate or, let's say, to verify their meters. It's independent of fluid composition, of course, so also no issues with flow profile or swirls, and no inlet and outlet are required. And since Coriolis measures the flow massing of the fluids, the flow mass, sorry, of the fluids, its accuracy is independent of fluid compositions, like I mentioned before, right? Also, something very important to add is, in addition, some Endress Hauser Coriolis meter have meter verification capabilities to allow the user to check the calibration of the meter. Of course, as well, the electronic sensors. The results from the meter verification procedures can be used according to AGA report number 11 to determine when the field or laboratory flow test should be complete. So this one, of course, has a big significant benefits for the users because, of course, will reduce the cost for field flow tests and gas applications. Limitations, of course, we have, let's say, line size up to DN400 or 16-inch. We don't have gas available packages. And I would say the higher initial cost of investment is higher in the short term, right? So I guess I'm running out of time already. So Janice, thank you.
Thank you very much, colleagues. It was an excellent presentation from all of you. It's not often heard from colleagues that there is also a limitation to a particular technology. People always talk about advantages with using a particular technology, but here we try to bring across a very transparent overview. When you are selecting your gas flow meter, certain times you have to select a particular technology because you want to have higher accuracy or maybe custody transfer. Other times you are maybe selecting a technology because you have less space, or maybe you want to optimize in terms of cost. We have some questions with us, colleagues. If you are ready, I will start with the questions now. Okay. So the first question is for Erwin. I have a separator and we have issues with wet gas condition. We are currently using DP measurement. Can we switch? What are the benefits if we switch over to gas ultrasonic, which you just presented?
Yeah, it's a very typical application. Separators, DP, is still a very often used measuring principle. Yeah, but the first key reason I see to consider the change of a DP measurement by an ultrasonic gas flow meter is the turn down. You have a much wider measuring range using a turn down. Then the second key reason is at the moment that the separator is undersized, or suddenly you have more liquid coming out of your well, you have a good chance that you get a wet gas situation and your orifice might not be able to deal properly with that. That is also solved with the Prosonic Flow G. And last but not least, the diagnostic capabilities. I mean, if at some point you discover that your DP measurement is not working properly anymore, the question is that since yesterday or since last year? You don't know how long you're measuring wrong. And with the diagnostic capability of a modern electronic ultrasonic flow meter, you can detect a technical problem of the meter actually almost instantly and act and take measures to that.
Excellent. That's true. Quite often during normal operation, the flow meter just works, but it's during the disturbance that you want to identify what's really happening. I think your diagnostic capabilities, which you mentioned, they help a lot over here. Thanks, Erwin. Next question is for Oliver. Oliver, are you ready?
Sure
The
enough.
question goes like the question goes like this. I think you mentioned something about other vortex flow meters using, I think, a different technology, a piezo sensor for, yeah, and ours, or the Endress Hauser, uses the one with capacitance. What is the big benefit over here?
I mean, the capacitance probe has the major benefit of robustness and also lifetime calibration. I mean, if you look at a typical piezo manufacturer, you will see that these guys will specify a drift over time. So major manufacturers of vortex will specify, for instance, 0.1% drift of reading over 1 year. So after 10 years, you will see 1% drift, whereas our meters come back after decades in the field and still showing the same calibration factor when we take them on our calibration rig. In addition, the other benefit is they're more robust when it comes to temperature shock, for instance. Imagine a piezo is also what you use in a pressure sensor. And a pressure sensor, you actually take it away in a steam service, for instance, and separate it by means of a pigtail. And in these vortex guys, you're directly at the process with your piezo. Our sensor consists of metal only, and therefore, even if you temperature shock it from 750 Fahrenheit down to cryogenic temperatures within seconds, it won't break, and it's still within calibration. So that's a major benefit if you compare these. So it's maybe the most robust vortex meter available on the market, I would say.
Excellent. Thanks a lot. Now I see, Matthew, that we have a few questions. I will try to make one question out of many which I have got. And it's all related to gas composition. And the question goes like this. Do we need to know the gas composition to input? So I think in your slide set, you showed that there is a gas analyzer giving an input into the TMAS. Now, if we don't have this, then how do we manage it in the TMAS? Matthew?
Okay, thank you, Shanish. That's correct. The gas composition needs to be known. That's important because, of course, the gas characteristics that are calculated by the device's software are used in the calculation of the mass flow, and those are gas dependent. So it's very important that the mixture is known and that is entered into the device software as accurately as possible. Now, if there are changes in the gas composition, there are two potential ways that one could deal with this issue. One is, like I mentioned, you could put a gas analyzer signal as an input signal to TMAS, and that would then compensate for change of a specific component in the gas mixture. So if you were dealing with natural gas, for example, you would probably want to input the methane component as the largest component, and that would then be adjusted dynamically according to changes in the methane content. The other components of that gas mixture then would be adjusted according to their relationship, their original relationship. That would be one way to deal with changes in the composition. Another potential way to deal with it is that we have what's called a second gas group. And in this case, you would configure your primary gas group. And then if you knew, for example, that you might have changes from one gas type to another, it could be that you receive monthly reports from your gas supplier that gives a breakdown of the composition, and then you could look for a particular type of gas, and you could enter then two different natural gas mixtures into the device and then switch between these two gases on demand. That would be the other way that I see of dealing with the issue of changing gas composition, but probably the best would be, if available, of course, is a gas analyzer.
Excellent. Matthew, I would like you to stay with me. I have one more question.
Sure.
This comes from Robert. We need SEAL 2 for vortex or TMAS. And is it limited for vortex if pressure and temperature input is used? Will this change?
I would turn that one over to Oliver. He's more
sure,
familiar with with the vortex.
Yeah, the SIL output of the vortex, if you are asking here pressure, temperature, they're not in the SIL loop. It's purely the volumetric signal. The actual volume is the only SIL relevant parameter here. Same applies, by the way, for Coriolis. Here it's the mass. The mass is the output that you get in SIL terms. Ultrasonic, Erwin, for you, I think it's actual volume as well.
It's true.
For you,
Fermi, volume.
And for you, Matthew, for you, you're the only one I think that's got corrected volume, or do you have mass as the SIL value?
Mass would be the primary output, yes.
Mass, okay. Yeah, that's the way it is. It's typically the primary variable that you're measuring using your that you're measuring.
Under the SEAL 2 compliance limitation, yes.
Yeah.
Then there is
no pressure and temperature, I'm afraid.
Actually, it was a bit difficult to even understand the question, but maybe we will get back to Robert on this. I think there's one more question. I think we're running out of time, but I'll just take this last one. How do you calibrate the thermal mass at factory? Is it real gas composition or HOR?
Yes, we use an air calibration, and the software does then, in the case of other gases, a so-called gas correlation. So there's a conversion from an air calibration to other gases. It is possible to calibrate the TMAS in other gases. However, we as Endress Hauser do not provide this service, so the customer would have to take that upon himself.
Okay. There is one last question which I would like to take. This comes from Reinaldo. I understand that your ultrasonic meter does not have a custody transfer certification. What is the best solution for us in this case? Reinaldo, I would just like to mention that yes, for larger line sizes, we sometimes collaborate with our partners for custody transfer applications as well. And that's how we complete our complete portfolio as well. Having said this, I think we have already run out of time for today's online seminar. Thanks, guys, for being so transparent in producing this content where you specify the technology, the advantage, and not only the advantage, but also the limitations of a particular technology when you're going for gas flow measurement. Any last words from my speakers, my experts?
Well, first of all, I would like to thank anyone for the time. And I guess the main message from Endress Hauser is that's why Endress Hauser invests in a very wide portfolio of technologies, because of course we understand that technologies has a different let's say performance and different applications. So it's very important for our customers to really understand what is the need and what is the right technology to choose from the complete portfolio the Endress Hauser has. Once again, thank you so much for your time.
Yeah, I'm absolutely with Rodrigo. We as Endress Hauser, we don't have to shoehorn a certain technology into an application. Whatever your problem, we've got the solution. I'm confident in that one. And we're people for process automation. That's the beauty. Over the decades, I'm working with Endress Hauser. It's always great people that you encounter, and let them support you in finding the answer to your problem. Thank you.
Thanks, guys. Erwin, yes. Matthew.
Yep. Thank you very much. I would always challenge our sales organization with your application. We will try to help find you a solution. Thank you very much for your time. Have a nice day.
Thanks. Thanks, Erwin.
Also
Great
from my
strategy.
side,
Bye-bye.
thank you very much, and have a good rest of your day.
That's the last words. Keep faith in us. We have variety of technologies. We want to challenge our salespeople. We'll be able to help you with one of the technologies. Thank you, guys. Stay safe. The handout is available for this presentation, and the questions which we could not handle right now, we will answer them offline directly by getting in contact with the participants. Thank you and have a good day.
Stay safe. Thank you.
Thank you.
Bye now.
Bye-bye.
Bye-bye.
Bye.
Bye.